My name is Stephen Spellicy. I work for a company called Guavus, which is actually part of the digital business within Talus. How many of you know Talus? Are you familiar with Talus? Great, great. So Guavus is a part of something called the digital business unit. And within that, there's a technology area where we're delivering analytics software to the market. Guavus caters to specifically analytics solutions that help communication service providers, or otherwise known as CSP. These are telecommunications providers that are seeking solutions to be able to better understand the information so they can make better decisions in real time. This has an impact to operational intelligence and operational analytics, as well as to better understanding their subscribers from a behavioral analysis perspective, which allows them to better interact and engage with their customers. So I run both product management and marketing for the company. And in my remit is to educate our customers and our partners and the rest of Talus about what we do. And today I've just put a quick presentation together for you, and we'll talk a little bit about how artificial intelligence can be used in a real operational as well as in a customer engagement manner that will help benefit the organization. Specifically, we'll talk a little bit here about why what we're doing is better than the old standard of not doing anything at all, not leveraging information to improve or transform your business. And by the way, I'm in a race against time because the laptop only has 23 minutes. It's got to go back to the charging station. I'm also going to talk about real-world examples. I'll give you some examples, and hopefully you'll feel familiar with these, because I think that does everyone have a mobile phone? Okay, everybody has a mobile phone. This is all about how telecommunication providers engage with their customers to make it better for you as you use those things in your hands. The last is the kind of tangible benefits that are delivered through AI and machine learning through our software that the provider can use to improve how they operate. Now, a little history lesson. Some of us are old enough to remember this, but when the whole notion of something called big data came around in about 2001, it was Gartner, who is an analyst who tells people what to buy in the IT industry, advises customers and helps companies position themselves to be purchased by other companies. Big data was essentially a term that came about in 2001, but the technologies that you know, and you hear big data all the time, it's effectively a massive amount of information, typically unstructured, and it can be semi-structured or structured data. Unstructured data is the things that we interact with every day, like files and pictures, photos, audio, video, and such. These are very rich media in content. They can have great context and information inside of them. There's other things like semi-structured data, like emails and things we share with people in structured organizational kind of ways, like file sharing, et cetera. And then lastly, databases. These are things that fit nicely in rows and columns, and you can index them, and you can search and find that information. And typically, most business productivity applications have databases or data structures like that. Big data tech comes to the market, and really what it's all about is helping people pull all of that information together. It started with effectively the decision-making, many companies here that you represent likely, around how you will actually build the infrastructure to actually support the aggregation of big data. It wasn't really as much about using the information, it was about how do I get it all together. And then after you did that, somewhere around mid-2014 or so, platforms emerged in the market, which is effectively a single way to manage and utilize your information. It was a big decision because this is how we manage and how we interact with the information. But still, it's not quite right. It's just a place for me to go and make sure that all my information is stored, and I can do some basic reporting and analytics about what it is I have. And then we move into sort of the 2016 into current state, right? It's all about the introduction of machine learning, artificial intelligence, and analytics to drive the business, to drive what we just heard, to better understand how to route packages, the best route to get you what you need. The cloud as well has emerged as a great option for analytics because the sheer horsepower that's required to process information based on the volume, the variety, and the velocity, the creation of data, is massive. And some computationally and from a storage perspective, It literally cannot be done on premise, or it's very hard to sustain that. So cloud and hybrid cloud, if you will, the use of cloud services to do this is very popular. Now the last piece is digital transformation. This is where you actually take the information and utilize it to influence how you operate as a business. I would argue that Cedric's example is using data and information to actually provide a better service. He's transforming how package delivery is done. Now, reality, guys, is that most of the companies we talk to are about right there. They've got the data platform, they've got some basic rules for management, they have an understanding of what they're storing, but they can't quite get to the next step. They desperately want to. A little more history. Analytics hits the scene, and it's broken up into 4 major categories, I would say. Descriptive analytics, such as what happened? Oh, the laptop didn't work. Why didn't it work? It's going to die from power failure soon. Why did it happen? Well, there must be a driver issue on the computer, I'm assuming, right? Or maybe something wrong with the network between this projector screen and this laptop. Will it happen again? Geez, I hope it doesn't happen again. You guys, I hope that thing stays up and running. And then how can we make it happen again? Is all about prescriptive analytics. This is effectively using the information to manipulate outcomes in order to achieve what you want. It's about hindsight. It's looking backwards, seeing what happened. It's about insight, what's happening right now. And it's about foresight, about what may happen in the future, whether I want it to or not. And by the way, as you move up this scale in complexity, the value goes up as well, proportionally. Now, machine learning is an advanced approach. You've just heard another presentation about this, more math-oriented than mine. Machine learning is effectively a capability delivered through mathematical algorithms, right? It's really intense math to be able to study patterns, to be able to deliver outcomes from a computational perspective. Artificial intelligence is effectively the embodiment of that in a practical way that can mimic or imitate human behavior. And we've got examples of this, like Alexa, when we ask her a question, or Siri, we're trying to find some location. These are things we interact with today. They feel like they're human, though they're really just computer-oriented, and they're learning all the time. And AI requires, although it has, some technologies have the ability to reason and some to even make decisions, it has to learn over and over again. It has to be fed information in order to get better and more accurate in what it does. A little bit about machine learning from a practical perspective. There's 2 modes, supervised and unsupervised. I'll give you a basic example of how supervised machine learning works. 1, I want to feed a bunch of images into a model and teach it about what this image is. So I label the information. I'm actually going to teach it by showing it something and labeling it and giving it an accurate label so that I can effectively force it to learn. It's like when you ask a child, what is this picture of? Is it a picture of a cow, or is it a picture of a bird? Is it a picture of a fish? No, it's a duck, okay? It has a bill, it has a beak, it has feathers, wings, and it has webbed feet, okay? So we all agree, right, that this is a duck, a canard. This is a canard, okay? And we all agree this is a canard. And then we see something that looks similar to it, and again, it's just part of the species. So I think we're probably okay with saying, you know, it looks like a duck, it quacks like a duck, it's probably a duck. So we agree, it's a duck. And then we see this little guy hopping around. Oh, he's cute, he's very cute. But he's not a duck. We don't know what he is yet, by the way. We don't care because he's not a duck. We're trying to see what is not a duck. Lastly, I pick up the newspaper and I read, Le canard, enchaîné. This must be a duck. No, it's not a duck. It may think it's a duck. There's no foie gras here, no foie gras. So I'm going to classify that out. Effectively, I am classifying everything that I see programmatically, and I'm effectively feeding that over and over into a predictive model. Now later, programmatically, when I start throwing things that aren't labeled at it, that match those rules, if you will, that things that it's learned through classification, it'll tell me that it's a duck. It's smart enough. Now, when I move to unsupervised, I'm looking at a far different outcome. These are not labeled. We're looking at advanced intelligence, and I'm going to flood the system with a variety of information. And it's going to use advanced algorithms like clustering to drive out observations that these 3 things all look like each other. They are likely the same thing. this thing is the only thing, and this thing is a complete outlier, okay? Or an anomaly in the data stream. These techniques are effectively training the model to be used programmatically for a practical application. The practical applications that we all care about relative to AI, such as how many of you have ever used your credit card and then received an alert on your phone that it's been a fraudulent activity, or it thinks it's fraudulent? I was in a store the other day. I was at the desk, I was paying, I was buying a pair of pants, and the lady behind the counter was helping me buy another pair of pants in a different store. She said, "Oh, just take your credit card and I'll buy it for you, and the other store will just charge it to your account." Well, what happened? My phone started buzzing. What's going on? You can't be in New York City and Boston at the same time and buy 2 pairs of pants. Fraud detection is very valuable for those kind of scenarios. They use advanced analytics and AI to be able to effectively work through a model to find these patterns, and the things that are anomalous will be called out. Other opportunities are things like watching what's going on, the browsing behavior, the application usage on the network, and understanding what likes or dislikes or interest a subscriber on a mobile phone may have. The great part about this, and if any of you have ever been on Amazon.com, it's a great website, you should check it out. In Amazon, isn't it ironic that sometimes it tells me what I want to buy and I'm thinking about it? Because it's figured out over time what I have interest in, and it's built categories and clusters of potential products that can be of benefit to me. Now, all of this falls short, miserably short, because when we approach these kind of projects, they're very difficult to execute. It's got to start, if you're building an application today as a startup, you've got to start with a strategy, minimum viable product, requirements from the market. It's got to be something that's going to be of value to someone. But when enterprises start to look at this information, they start to run to the technology. And effectively where it breaks is because they haven't really thought through the process. The other piece is when they go to production, the scale isn't there to actually process that massive volume of information. And then finally, they never even get to the last part because the idea of everything that they were trying to accomplish is a fail. And they have no repeatable operating model to be able to achieve the outcome that they desire. Now, it fails principally because this process is complex. It's a massive process that requires multi-phase. The problem that we see in our customers is, 1, it's very long, drawn out, and complex, as I said. 2, it requires a highly skilled labor force. And 3, it requires lots of retooling, understanding data, and reworking the model. It's very difficult if it's not automated. What we do with our customers in our technology is we enable them to utilize the AI programmatically in our product to be able to reduce outages in the mobile network, to be able to figure out patterns in the network that are indicative of potential failures, outages that will come to fruition in the future. In addition, the ability to understand and reason what's going on in the network so that we can provide them recommendations and lower the mean time to understand and the mean time to recover. It's very important. The other piece that's really important is that when they start working with these technologies, they can't be too manual in nature or they will constantly require maintenance. It's very difficult. So it can't be statically defined, it has to be automated, and it needs to be artificial intelligence in nature. The other thing is, if there are not enough people to staff the operation, they're looking for the system to make decisions, and it needs to be straightforward and easy. I'll give you an example before I end my presentation about how we're helping customers with their problems in AI. Specifically, operationally, we're helping customers who are running very large networks, subscriber networks of the size of hundreds of millions. Some of our customers have upwards of 400 million subscribers, the largest networks in the world. They're looking to reduce the amount of time it takes to resolve problems, and they're using advanced analytics and AI through our products to be able to pinpoint problems, spot anomalies, and then quickly allow the operator or the engineer to be able to fix a problem. In many cases, fix a problem before the subscriber knows they have a problem, which is ultimately the goal of the operation. In this particular cable operator, which is a large US-based company, they use the technology, and because of it, they save roughly 70 million USD per year. Another example is on how this whole flood of information from a network perspective is literally causing a team that manages the infrastructure not to be able to fix problems in real time. The problems that we're solving and that many companies who are deploying AI technologies is they want the insights to happen in real time so they can solve those issues without affecting services. Ultimately, this is about taking insights in real time and applying fixes, in many cases automating those fixes so that the customer will be up and running. Lastly, from a monetization perspective, these same providers are using the technology to better understand how they can engage and keep the customer happy. Most of you, I don't know, most of you, some of you are millennials, you probably never want to call anyone. You use text, you use SMS, you use chat, whatnot. Guess what? The mobile provider, Orange, they don't want you to call either, honestly. What they want you to do is interact on the platform of your choice so you can solve your problem in a few clicks, and they can get you back up and running. In this case, we were helping one international mobile provider with a solution to gain further and deeper insight into how their subscribers were behaving, their likes, their dislikes, and their interests. In this case, we were helping them with a promotional campaign to drive a higher download and conversion rate through the analysis of mobile traffic, through the use of an application that was on Android and on an iPhone. With the technology, we have the ability to look at static analysis and dynamic segmentation. That means we can just basically take a bunch of statistics and make observations, or we can literally let the system find those observations, tease those observations out, and make recommendations. We ran the dynamic profiling on their particular campaign, and we were able to increase their conversion rate from under 1 download every SMS advertisement to over 4 downloads per 100 SMS recipients. This means that when they sent out the first campaign, less than 1 person clicked for every 100 that they sent it to. When they returned it and used the appropriate insight from the technology that we offer, they increased the conversion rate to roughly 8%, which meant a return on their download rate and ultimately a return on revenue. So I'll end there. We're helping very big companies, some of which you know, in the telecommunications space. But this technology can be used in other verticals and industries. Preventative maintenance, from a security context, looking at transportation patterns, as well as looking at things like flights as well. This is, from a Guavus and Thales perspective, the technology is extensible across multiple domains and multiple industries. Thank you very much. And again, apologies for the disruption. Thank you.
Stefan, we're running behind the time, so I have a first question. Perhaps could you tell us more about, do you have any, do you craft different open source solution, or do you have your own solution? How does it work?
The technology is a packaged application we sell to customers. However, there are many open source components that are a part of that solution. Any software developer today, any company, any startup is going to leverage open source to improve the time to market of their product. As well, we contribute back to open source communities, so the things that we build on our products, and we bring that back to the community so others can benefit from it. We're very big in the Hadoop community, Spark, as well as in the data pipeline management with Google CDAP.
Okay. Any question? Yeah.
Just wondering the quantity of IP that you have in your engine, whether or not it's you were talking about open source. Is your positioning more consulting company in the equation, or do you have a recipe that fits all the requirements?
Without giving you a product presentation, which is not my intent today, in the core of our product we have a high performance ingest capability. We process every day roughly about 5 petabytes of information. We provide real-time insights for these providers so they can actually act and really serve their customers better. So that requires massive horsepower. So we built in scaling, horizontal scaling, we've built in forms of fault tolerance, high availability and such, and then invested in those areas both within the open source as well as on our own, with our own intellectual property. But in the core of our platform, we have an analytics engine which has very specific analytics modules that have been fine-tuned and tailored towards telecom-oriented use cases. When you find yourself developing software in the analytics space, it's best to start with a use case and then to rally that effort around a domain or a specific vertical use case. So in this case, the company has 12 plus years of experience in telecom. Everyone who works there has come relatively from the telecom industry, has a very good familiarity with it. So we bring that to the table. So our domain expertise. But the modules that we've built and the IP that we've created is around analytics are specifically highly instrumented analytics that cater to telecom. So that very focused on that vertical.
Okay, last question perhaps.
Yeah, just a quick question. It seems very interesting to use the data. How do you use cross-fertilization, or can you share customer data amongst different customers to build your model? And how do you, because the more data you have, probably the more the model is fitted.
Yeah, obviously it would improve as you see new data, right? In our model, we sell typically on-premise perpetual licensed software. So we're selling software to a telecommunication provider like Orange or Bouygues or somebody like that. They're implementing that in their network. At that moment, we're kind of away from the information. We're not the information, the insights are not directly visible to us anymore. The sharing of the model is not done between customers. I see the value in what you're saying, though, because as you instrument the model and you learn more and more, it could be a benefit to all customers. We try to do that from the observations we make from the use cases that we build and make them more cross-customer relevant.
Thank you, Stefan.
Thank you.
We're going to move on.
Thank you
Please,
so much.
David.